Hello and welcome back to the channel. Hey, I'm Ron with Ideal Industries. In this segment we're not going to talk about datacom, we're going to talk about testers and meters, and specifically Ideal testers and meters. And in this group of product in front of me, this is more or less what we call our Resi Pro line of testers, and it's kind of our entry-level thing for test equipment for people. And if you're looking for hiring great quality testers and testers that do some unique different things, go check out the Ideal website. You'll find that we have a variety of testers for lots of different applications you might run out there. Okay. Now, in this group of products, this is a group of products that just about anybody can afford to own. These start in the $20 range and go up from there. And they're great meters for working around the home, or for the remodeler, or the homeowner themselves, or even the entry-level pro type person buying their first meter that they want to get into. So these are great testers, and in this segment we're going to start with the 61-312, which is our auto ranging tester, and it's a step up from the 61-310 here, which is not an auto ranging tester. So let's take a close-up view of the 61-312, and I'll walk you around the dial. Here's an up-close look at the Ideal 61-312 digital multimeter, and when I look at the tester, I see 3 ports here that we can put our test leads in, which we'll play with in a minute. Got a dial here, obviously, with the different settings around the dial, and this is an auto-ranging tester. There's only one setting for volts, one setting for resistance, and we don't have to worry about what range we might be in as far as resistance or whatever it is. Now there's a select button to check whether we want AC or DC or whatever it might be, one of the other functions. There's a hold button that will hold whatever the tester might be reading at the time. And then of course the display in the front. And when I look at the tester, one of the first things I'll show you here is the tester says Cat 2 right there, and what that indicates to me is the tester is designed to be used inside of homes and at branch circuits, electrical outlets, lighting, appliances, those kinds of places. So this is a pretty popular little tester. It can be used in a lot of different areas. Now when I look at the different ports on my tester, I've got to put the black port in the one that says common. The red lead can go actually on either side here, but here you'll notice this is 10A, which means 10 amps, AC or DC, and the tester will measure up to 10 amps, and if I need to, I'd have to have the red lead in that setting. But over here you'll see a V for voltage, a omega symbol for resistance, a capacitor symbol for capacitance. Hertz means frequency, milliamps is what that stands for, and then of course temperature. So in most cases your red lead is going to be over here. Now, one of the first things we'll ask you to do when you're working with a tester is to make sure the tester is actually working properly, and so we're going to do that. I'm going to set the tester in this setting here, and the 2 symbols you see there, one is a diode and the one right above it looks like an audible symbol, and the tester here says OL, or that means overload, and it's got that audible symbol over here. If I hit the switch, the select button, it would toggle over to the diode setting, and we'll mess with that in a moment. But here it's in the OL. Now what that means is that it's checking for a resistance, and it doesn't see any resistance at all. It's an open because I don't have the test leads together, but you'll notice if I touch the leads together, the tester will go down to 0, and it gives me this audible tone that hey, things are working, and tester's working, the test leads are working, and one of the first things you're taught is to make sure the tester's working, because you never know, it could be the test leads are bad. And that audible indication helps us when we're checking for continuity through devices, and here I've got a little pretty beat up old single pole switch, but if I go across the switch here and I've got no reading at all, obviously I have my light switch open. If I close my light switch and hit the test, and now it's giving me that audible tone, and for instance my light switch is working now. Now if I wanted to check, say, this little fuse here, I could, and this is one of the fuses that is in the meter if you ever end up blowing it accidentally. If I go across the fuse, oops, give me an indication that yes, it's an audible tone, and it's going down to about 6 amps, or 6 ohms there I should say. And so that fuse is actually good. Okay. And so those are a couple settings we might use that particular functions for. Okay, and the other one right next to it is diode. So if I go back over here and hit the select button and I go to the diode setting, a diode is basically an electronic device that only lets current flow through it in one direction. And you're going to see here this little black device is a diode. If I put my test leads across the diode, and you notice I'm getting nothing on the tester, that's indicated to me that, well, the diode should only let current flow through it in one direction, so it's not flowing through it in that direction. Now I'm going to change the test leads around, and now it's showing me about a half a volt there, and it is allowing current to flow through it in this direction. I've just changed the test leads around, and that tells me that diode is good. If the diode gives you no reading in either direction, well, then that would be bad. All right, now let's go over here and let's play with the voltage setting. And when I'm looking at voltage, it is giving me a little bit of a reading, and it's reading a very small amount of voltage here, which is just coming across the test leads here. And it is measuring AC as it shows right there. So if I want to measure AC, I'll take an extension cord here and plug the leads into it, and it's taking a reading for me of about, pretty close to 119 volts. And if I took the test leads and actually reversed them, it should still give me that same reading. Oops. Okay, or pretty close to. And by the way, if you ever want to use the hold button, and say I can't quite read the tester because I've got to touch these leads together, and I hit the hold button, you'll see the hold function comes on, the little light does. And if I take the test leads out of the outlet, it is actually holding that last reading that it saw. And if I hit the hold button one more time, it goes away. Now, for DC, if I hit the little toggle switch and it goes now to DC, I can measure a battery here if I wanted to. And the bigger of the two openings is the black one for the negative. So that is reading about 9.5 volts. And if I had reversed my test leads, it would give me a minus 9.5 volts. So your test leads are backwards. So there we go as far as measuring basically AC and DC voltages. Now, the little omega symbol here is resistance, and so if we move it up there, it is going to measure the resistance, and it is now showing me OL, meaning overload, and it's because, again, the test leads are not touching. So if I touch them together, it is now going to go down to 0, but this time it's not going to give me the audible tone that I got when I had it in the audible symbol over here. Okay, so if I need to measure resistance in a lot of different things, motors, windings, and other devices, I'll notice on my little printed circuit board here, I have a couple resistors, and they're right here, and there's one of them. I go across one of these resistors, and the tester is checking the resistance here, and it's coming back at about 180 ohms of resistance. Now, the two resistors here are actually side by side, are wired on what we call series wiring. It's almost like taking two D-cell batteries and putting them together in a flashlight. And two devices in series are going to basically be added together. And so since these are both 180 ohm resistors, we're reading pretty close to 360 ohms here across those two. And that is how we would go about measuring the resistance of a wire or whatever we might be looking for. Now, the diode setting we did, the capacitance here, the blue device on my board is a capacitor, and there's a couple different ways of actually measuring capacitance. And in this case, what we're going to do is this tester is going to go across the capacitor and have the positive on the positive end of the capacitor, and the tester is giving us a reading. Now, the way this tester is measuring the capacitance is actually going to charge the capacitor, and then it's going to measure whether or not it's holding its charge over time, because that's what we need it to do. A capacitor is going to hold a charge, and it will dissipate it very quickly when it's asked to, but we need it to hold its charge over time. And so the test is going to take, depending on the size of the capacitor you're measuring, this could be 30 seconds, it could be 40 seconds, or maybe even a little further. And there it popped up, and it finally went 146 or 164. 0.6, so this is really about 165 microfarads there, capacitor, and it's not really going to change anymore if I hold it here any longer. So usually within about 30, maybe 40 seconds, minute the most, it's made its measurement on that capacitor. So you want to hold it on it for a little bit of time. Now, the frequency setting here, hertz. If I turn it to hertz. The tester is designed to measure very high frequencies if it needs to, for like an electronic circuits and so forth, and it can measure thousands of hertz basically. And because of that, the tester is actually fairly sensitive, more or less designed for electronic stuff. And because of that, when I take the tester and I run it into normal AC, which should be 60 hertz, you're going to see that it's jumping all over the board here, and sometimes it's running 60, 70, 80, 90, sometimes well over 100. And the reason is because the AC flowing through our homes today is not actually a clean AC 60 hertz cycle frequency sine wave. And because many of the devices in our homes that have microprocessors in them will have power supplies that will obviously convert AC to DC. In the process, they will add what we call harmonics or noise into the circuits. And so the tester is actually seeing this noise as well. And so in order to filter that out, and testers that are designed to measure AC frequencies do have filters in them, but I could use maybe a simple device here like this surge device here, and I'm going to plug the tester into an outlet over here and make a measurement, and you're seeing it's measuring right at 60 hertz. And because actually the electronics inside this surge device is actually filtering that noise I was talking about. So if you're having a hard time measuring household frequencies, keep that in mind with this tester. Now you'll also see some current settings over here. We have microamps and we have milliamps and of course 10 amps here. And I'm going to go to the milliamp setting. And I'm going to put my battery in my little board here. And the little board here will allow us to measure current here. Now we're measuring current with this type of a device. Oops. Or a tester, I should say, digital multimeter. We actually need to make the tester part of the circuit. And to do that, I'm going to take these little alligator clips and I'm going to put them on the test leads here. And I'm going to put that on the little board. And it lit up my little light there, you can see. Okay. And the current is actually flowing through the tester. Oops. You notice it was in AC, not DC. See, I had AC. I'm doing DC, obviously I'm doing battery, toggle over to DC. And it showed me I'm pulling about 6 milliamps of current through this board that's lighting up the little light. Now the little potentiometer, I can change that, and it's going to change the amount of current flowing. And of course my light bulb got a little brighter as well. And of course I crank it all the way up. The light bulb gets pretty bright. And you're pulling about 20 milliamps of current here through the tester now. And again, with digital multimeters, you always have to make sure that the current's flowing through the tester, which is why we'll use clamp meters again for high currents. And here we are again measuring milliamps of current. Again, if I turn it all the way down, the light bulb goes a little dimmer, and it goes down to about 7 milliamps. And if I disconnect one of the leads, it breaks the circuit, and no current is flowing out. And that is measuring current flow through the tester. Now if I'm going to measure temperature over here, I'm going to take these test leads out of the tester. And to measure temperature, you'll need to utilize the temperature, the thermocouple that came with the tester. You notice on the thermocouple there's a positive and negative symbol on the thermocouple. And when I install that into the tester, it goes into these two holes here. The negative goes into the common. Okay. And the other will go into this side where it says temp. And of course the little probe here, this little tip is actually measuring now temperature. Okay, and we're measuring 70-some degrees. Now you might let the tester kind of settle here. It may take a few 30 seconds here to kind of settle down as far as the temperature is concerned, where it's not changing again. And of course if I test the into the probe, it's going to go up in temperature. Okay, and again we can test and check for either Fahrenheit or Celsius if we want to do this. Now if you ever want to really calibrate your tester for temperature, there are means of doing that, and if you check out Ideal's website, you'll find a white paper on how to do that. Now if for whatever reason you have to change the batteries out in the tester, I'm going to take that out of there. To change the batteries in this tester, you turn the tester around backwards, you'll find, by the way, first of all, a little plastic stand for the tester if you ever need to stand it up. Okay, I will take the rubber boot off of it. Okay. and turn the tester around backwards, and this compartment's got 2 screws here which I've already removed, and when we do that we'll take that off of there, and the battery slides in and out of here. And inside this sleeve are 2 1.5 volt AA batteries. Okay, alright, and you'll also notice a couple screws right here. If I ever have to replace that fuse that we showed you a little earlier because it has been blown, we'd have to remove these 2 screws, which allow us to take the back off the tester, and we'd have to then pop the fuse out and put the new one in. Alright, well there you go. That's the 61-312 Ideal Digital Multimeter, and thanks for coming to another segment. I'm Ron with Ideal Industries, and we'll plan on seeing you next time.